Okay, hello everyone. I am going to go over the linear programming take-home test problem you have. I presented this problem on 1026. I will go over it again so you know what to do. I will be introducing Desmos as well. So you'll see that there's very little calculations you have to do with this problem. But let's review what I presented on 1026, and you certainly can look at the video that I posted for 1026 as well. But here we have Leela, and she's selling hot dogs and hamburgers at the senior cookout. She has $80 for hot dogs or hamburger buns. Each hot dog or hamburger bun costs $1. She has $100 for hot dogs or hamburger meat. Each hot dog costs $1 and each hamburger costs $2. So what you have to do, you have to define your variables that will help you write the two constraints for this problem. For example, X is equal to the number of hamsters in the cage and Y is equal to the number of pigs in a cage. Actually, you'll have four constraints, and you'll see what I mean. So you'll actually have four constraints. So number one, what you have to do, and you have to type that into the essay box down there. You have to type that into the essay box. And please number your responses as well. Okay, number your responses. So number one, you define your variables. So that's what I did. So I said X is equal to the number of hot dogs sold and Y is equal to the number of hamburgers sold. So that's number one done. Number two, you have to, so I did one. Number two, you have to, so write your constraint equations for bun and meat and your non-negative constraints. You can't have a negative number of hot dogs and a negative number of hamburgers. So the first constraint, the bun constraint, is that, again, for buns, each hot dog bun costs $1 and each hamburger bun costs $1. So we have our bun constraint there. So X plus Y, or 1X plus 1Y, it has to be less than or equal to $80. That's our bun constraint. And the other constraint sheet we have is we have a constraint on how much she can spend on meat. So each hot dog costs $1 and each hamburger costs $2. So $1 times X plus $2 times Y, it has to be less than or equal to 100. She only has $100 to spend on meat. So that's our meat constraint. And then the other constraint we have, which is important to list, and you'll see why when we go to graph this using Desmos, we have to list our non-negative constraint as well. Both X and Y, it has to be greater than or equal to 0. Okay, so we have our four constraints: our bun constraint, our meat constraint, and our non-negative constraint. So what we're going to do, and I'll introduce Desmos, we're going to use Desmos to actually help us graph the feasible region and find the corner points, okay? You don't have to do this. We're going to have Desmos do it for us. So these take-home tests are always technology, okay? You get to use technology. So I'm going to go out to Desmos, and Desmos is in the resources folder for the Schoology course. And you can click in there. So let's look at Desmos. So I've gone out to Desmos. So here we're going to type in our constraints there. So here I'll use, so the first constraint was X plus Y. And then I'll use this little table down here because we wanted inequality is less than or equal to, it was 80. Okay, so if I go back out here, 1X plus 1Y was less than or equal to 80. And then I press enter. And the next one was 1X plus 2Y, plus 2Y. And again, I'll use my less than or is less than or equal to 100. And as you can see, as I zoom out or zoom in, it's starting to graph that for me. All right, so the feasible region now looks like that dark purple, but we have to add in our non-negative constraints. So X has to be greater than or equal to 0, and then Y has to be greater than or equal to 0. And now you see we get our feasible region is the dark purple there. Okay, so we use Desmos to do that. Now to get the corner point, all you have to do is just click on the corner points. And so there's one corner point, 0, 0. Here's another corner point, 0, 50. Here's another corner point, 60, 20. And then here's the other corner point, 80, 0. So we found our corner points of our feasible region, 0, 0, 0, 50, 60, 20, and 80, 0. So let's go back. All right. So we did number 3. We graphed the system of inequalities using Desmos and list the corner points, which is what I did there. So we did number 3, and I listed them down there. So we've taken care of 1, 2, and 3. And again, you would do that in that text box. So I listed the corner points. Number 4, okay, if Leela can sell hot dogs for $2.75 and hamburgers for $3.50, using the corner points, determine the corner point that will result in maximum profit. Okay, so I have to evaluate use. So she can sell each hot dog for $2.75 and each hamburger for $3.50. So if I use the corner point 0, 0, 0, 50, 60, 20, 80, 0, and I substitute an x and y for each x and y into my equation, 2.75x plus 3.5y, the largest value I get that you see happens when the number of hot dogs sold are 20 and the number of hamburgers sold are 60, I'm sorry, for hot dogs, and 20 for hamburgers. And that will be, she'll have $235. Okay, so number 4, it says list the corner point where the maximum profit occurs, and I did that, 60, 20, and then indicate the maximum profit, and I did that, 235. Okay, so you'll have problems like this. They will be exactly like this, and then you'll get to use Desmos to help you answer the problem. But again, make sure you number your responses 1, 2, 3, 4, and 5 in your response box, just like I did.